Now, moving along, we've already done G. Let's look at H. Well, H looks pretty messy. We've got, let's see, a P to the negative 1/4, a Q to the negative 3/2, all over a 3 to the negative 1st, a P to the negative 2nd, and a Q to the negative 2/3. And then this whole thing is raised to a negative 2. So normally I would be very worried that I see this negative exponent on the outside, but I'm less worried because there are negative exponents on everything on the inside as well. So the first thing I'm going to do is I'm going to take this negative exponent on the outside because of the parentheses, and I'm going to distribute it or multiply it to everything on the inside with an exponent. So let's see what happens. On top, when we distribute exponents, we'll get a negative 2, which is negative 2 over 1. Times the negative 1/4. Well, a negative times a negative is a positive. The 1/4 times the 2 will get me a, let's see, 2/4. And again, you could reduce that, but maybe it'll help me out later with a common denominator. The next term we had up top was a Q. So let's see what happens there. Again, I'm multiplying the negative 2 times the negative 3/2. Well, right off the bat, a negative times a negative is a positive, and that will get me a positive 6/2. Continuing along to the bottom. On the bottom, looking at the 3 to the negative 1. Again, when we take the negative 1 exponent and the negative 2 exponent and multiply them, the base stays the same as a 3, but the exponents become negative 2 times negative 1 is positive 2. Let's look at the next term on the bottom, the P. Again, we've got a negative 2 times a negative 2, which would just be a negative 4 on the bottom. And a Q to the, well, we've got a negative 2/3 times a negative 2, which will give me a positive 4/3. Well, right off the bat, let's see what we can do. Well, the quickest one here is the 3 squared. Well, 3 squared is just 3 times 3, which is 9. It's just telling me that there's going to be a 9 there on the bottom. Now, let's take a look at P's next. We've got a P to the 2/4 over a P to the negative 4th. Well, there's a couple of ways we can handle this. We could just take the P with the negative exponent and move it up to the top. And it will turn into a P to the positive 4th, and we'll just move it from the bottom to the top, and it becomes a P to the positive 4th. Then, once they're both on top, you can just add exponents, because then you're back to multiplying. Well, that gives you a 4/1 plus a 2/4. Then what do you need, though? You need a common denominator of 4. Well, your second one already has a 4 on the bottom and a 2 on top. That just means your 4 or 4/1 would have to get multiplied by a 4 as well, which would give you 16/4. So when you go ahead and add those up, the 16/4 and the 2/4, you would get a, let's see, 18/4, which reduces to a 9/2. What that gives you for your P's is a P to the 9/2. And again, notice that 9/2 was positive, which will leave your P's on top. The last part, the hardest part, is dealing with the Q's. With the Q's, we have a Q to the 6/2 over a Q to the 4/3. You're dividing though. So how do you divide? Well, you subtract the exponents, which is a 6/2 minus a 4/3. It means I need a common denominator of 6. Well, the first fraction has a 2 on the bottom. So to get the 6, we'll multiply by 3, which will give me an 18/6. The second fraction has a 3 on the bottom. We need a 6, so it'll get multiplied by 2, which will give me an 8 over 6. But then that at least gets me a common denominator of 6, let's see, which will give me, on top, the 18 minus 8 will give me a 10 over 6. Again, be careful, that's a regular fraction. It can be reduced by dividing both by 2, which will give me a 5/3, which tells me my q's, when combined, will be giving me a q to the 5/3. Notice it's a positive 5/3, so it will be on the top. So this is my final answer. It's p to the 9/2 and q to the 5/3 on top, all over just a 9. Continuing along, let's look at I. In I, we've got x to the 5/8 times 3x to the 5/8 plus 5x to the 11/8. If you didn't see fancy fractional exponents here, the question is, what would be your first thought given these parentheses here? Well, your first thought should be that there's something out in front, there's parentheses, I should probably multiply or distribute this out. And that's exactly what we're going to do. Okay, well, when I multiply those first two pieces out, the x to the 5/8 and the 3x to the 5/8, well, notice I just have for the numbers, I just have a 1 times a 3, which is 3. X to the, well, what do you do when you're multiplying? What do you do to exponents? You're going to add exponents. Well, 5/8 added to 5/8 will give you 10/8, which reduces to 5/4. So that'll give me a 3x to the 5/4. Now, for my last part here, I have to take that 5/8 and multiply it out to the 5 times x to the 11/8. So let's see. So the first thing that you've got there is a 1 times a 5, which is a 5. And then you've got the 5/8 and 11/8. Again, when you're multiplying, what do you do to the exponents? You add them. So I take the 5/8 and add it to 11/8, which is going to give me 16/8. Well, that actually divides or reduces evenly just to the number 2. So that will give me just an x with the new exponent here, which was 2. So be careful, though. Right now, you've got a 3x to the 5/4 plus a 5x squared. Notice you cannot add these. You have to leave them as separate terms because they're not like terms. They both have different amounts of x's. This one has 3 of these x to the 5/4, and this one has 5 of the x squareds. They are not like terms. You cannot combine them. You are just stuck with them as is.